A modern family dinner is a multi-sensory experience. We eat for comfort, joy, and the deliberate combination of savory, sweet, and bitter flavors. But when we picture ancient human diets, we imagine a much bleaker scenario. The classic museum diorama usually features early humans huddled around a raw carcass, strictly consuming meat to survive. This grim picture is the result of an archaeological bias. Stone tools and thick animal bones survive easily in the dirt for tens of thousands of years. Fragile plant matter, seeds, and gathered herbs simply rot away, leaving behind no obvious physical trace. Because science lost the physical evidence of these plants, we lost the human side of our ancestors. The history of the human diet skewed heavily toward the hunt, with the culture of gathering and preparation completely erased. The missing evidence for those ancient meals was eventually found in an unlikely place: the thick crust of calcified plaque stuck to ancient teeth. Dental plaque is a sticky biofilm that builds up naturally. During a person's lifetime, the minerals in their saliva interact with this plaque, causing it to harden into calculus. It mineralizes into a protective shell over the tooth enamel. This biological byproduct functions as an indestructible, intimate diary of a person's daily life and environment. The moment a bite of food is taken, saliva goes to work. Before the food is even swallowed, tiny starch grains, plant fibers, and pollen get swept up in the plaque, safely embedded before stomach acids or time can break them down. When researchers examined the dental calculus of Neanderthals and early modern humans, they found it packed with plant microremains. They identified the distinct microscopic signatures of wild grasses, barley, and roasted tubers. The calculus also contained traces of sharp, distinctive flavors, like wild mustard, bitter almonds, and tannin-rich wild fruits. These particular plants offer very little nutritional value or calories, but they are incredibly flavorful. Their presence in the fossil record shows ancient humans were deliberately adding seasonings to their meals. By intentionally combining bitter, sharp, and savory ingredients to create specific flavor profiles, Paleolithic humans operated as creative chefs tens of thousands of years ago. We can also read these microscopic diaries to see how later populations survived extreme challenges. In the Cantabrian Mountains of northern Spain, early migrating farmers faced steep, rocky terrain and a wet, oceanic climate. To understand how they fed themselves, scientists extract tiny flakes of dental calculus from their remains. They carefully dissolve the mineral matrix in a weak hydrochloric acid solution, freeing the trapped microfossils. Inside, researchers found specific, large starch grains belonging to the Triticeae tribe, a botanical family that includes wheat and barley. These starches have a distinctive bimodal shape, identifying them under a microscope. Cultivating this hulled wheat was the perfect strategy, as its tough outer layer is highly tolerant of poor, wet soils and resistant to fungal diseases in a mountainous environment. By extracting and measuring stable carbon and nitrogen isotopes from bulk calculus, scientists can track exactly what these populations were eating. The wide, scattered distribution of points on this isotope plot reveals extreme dietary variance and intense survival stress. Later, the record shifts alongside the appearance of millets. Providing 2 growing seasons, millets represent a successful evolution into a much more stable farming economy. Through these microscopic starches and isotopic signatures, we can map the innovative struggle of early farming communities as they adapted their agriculture to stay alive. The evidence locked inside ancient teeth dismantles the stereotype of the mindless cave dweller. We can now clearly picture ancient, weathered hands tending a fire, carefully sprinkling gathered wild herbs into a simmering cooking vessel to feed their family. While the measurements of stable isotopes and the morphological breakdown of starch grains are highly clinical, the story they tell is deeply familiar. Dental plaque is something we routinely scrape away at the dentist, yet for archaeologists, it has become the ultimate historical archive, offering the most intimate look at human life ever discovered. Creating a meal, seeking out specific flavors, and sharing that food with others is a universal human experience. It is an unbroken cultural thread that connects us directly to our ancestors, stretching back across tens of thousands of years.